This video covers section 8.5, Linear Functions and Models, Objective 4, Build linear models from data. If a set of data have more than 2 points, how can we tell whether the data are linearly related? We will draw a picture of the data, a scattergram, and see if the data might be linearly related. In letters A and B, the data all seem to fit on or fit closely to this same line. In letter B, this line that they seem to fit is going down. Whereas C, D, and E, the data does look to be predictable, however, predictable by a nonlinear curve. So if we look at our data, we can see if it's linearly related. Example 5, we will examine if this data are linear related. The data below represents the total cholesterol in milligrams per deciliter and age of males. The age of the person is X, and Y is the total cholesterol in milligrams per deciliter. So a 25-year-old might have a cholesterol level of 180. They could also have a cholesterol level of 195. A 28-year-old was found to have a cholesterol level of 186. A 32-year-old of 180. And another 32-year-old of 197. A 38-year-old was found to have a cholesterol level of 239. And a 48-year-old of 204. A 51-year-old was found to have a cholesterol level of 243. And a 62-year-old was found to have a cholesterol level of 228. A 65-year-old was found to have a cholesterol level of 269. And so there's the scattergram of the data. Is the data linearly related? It looks like this data is linearly related because we can find a line that comes close to all of the data. Coming up with the line that fits the data the best is a topic taught in statistics called linear regression. This is beyond the scope of this course, so we do this another way. We choose 2 points and find a linear model that describes the relation between the 2 points. But the 2 points that we choose, we want that line to be a good representative of all of the points. So we have a lot of choices here. We could choose these 2 points, but all the data is below those 2 points, so that's not a good choice. Likewise, these 2 points down here at the bottom, bad choice as well. We could choose these 2 points, but that's a bad choice as well because we see this data seems to be going up, meaning this data leads us to believe that the cholesterol seems to be raising or rising as these males are getting older. So this choice is really up to you. For me, it seems like this first point and this last point is a good representative Now you might argue that this third point and the last is also a good representative, and I couldn't argue with you there. This one and the last one, that might be a little too steep, so I'm going to go with the first and the last. Letter B, yes, it appears. That the data are linearly related. We selected our 2 points, 25, 180, and 65, 269. So now we need to find the linear model that describes the relation between these 2 points. So we start off with our slope. y2 minus y1. That changes in 89 over a span of 25 to 65, or 65 minus 25, or 40 years. So according to these 2 points, cholesterol goes up by 89 milligrams per deciliter in 40 years. Now we choose the point, 25, 180, and we use x equals 25, y equals 180. Times 25 over 1. 5 goes into 25, 5, and into 48 times. That's 5 times 89, 445. This says that B is 180 minus 445 over 8. Common denominator of 8. 8 times 180 is 1440. Giving us 995 eighths. So B is 995 over 8. Or Y equals 89 40ths x plus 995 over 8. We've graphed the line on the scattergram by connecting the 2 dots that we chose, or 2 points we chose. And C, predict the total cholesterol of a 39-year-old male. So if x equals 39, from the graph, the 39-year-old male looks to be about maybe 210, 212, something like that. And from the equation, y equals 89/40 x plus 995 over 8. Plugging in 39. This gives us a cholesterol of 211.15 milligrams per deciliter. Letter D, interpret the slope. Does it make sense to interpret the y-intercept? Interpret the slope. The slope is 89/40, so cholesterol increases by 89 milligram per deciliter as the male gets 40 years older. In this case, it's probably a little more suitable to say that 89 over 40 is 2.225. So each year, the cholesterol goes up by about 2 milligrams per deciliter. The y-intercept. Zero, 995/8. 995/8 is 124.375. So that means if a male is 0 years old, the cholesterol is 124.375 milligrams per deciliter. It really doesn't make any sense for us to test the cholesterol level of a 0-year-old male. So this doesn't make any sense. And this concludes the video for section 8.5, linear functions and models. Objective 4, build linear models from data.